Okay, good afternoon, students. So, today we'll go for the next chapter that is called as P block elements. So, all of you know that this chapter comes in inorganic chemistry for first PUC as well as second PUC. Theoretically, it is a lengthy chapter, and from this, nearly two questions will be asked in exams. So, today and next session, I will be discussing few questions on all the groups present in the P block, that is from 13th group to 18th group. As you know, 13th group is called as boron family, 14th group is called as carbon family, 15th group nicogens, 16th group chalcogens, 17th group halogens, and 18th group noble gases. From first PUC, 13th and 14th group, second PUC remaining groups we are learning, and we come across many reactions in this chapter and some structures and some processes. Okay, so some general properties also will be there. They may ask regarding uses also. So one by one we'll start telling the question. It may be of any group, but mixed questions will be there. So as you see, the first question on the board, that is P4O10 is the anhydride of. So first you should understand what you mean by anhydride. Hydride means containing water. Anhydride means removal of water. Okay. So here you are observing some oxo acids of phosphorus. From that you have to remove the water so that you should get the phosphorus pentoxide dimer. Okay. So easily you can guess the answer, that is P4. And here only 1P, 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 and here 2P are there. So for example, what to do for this one? I want 4 phosphorus. Therefore, I will make it as 2 moles of H4P2O7. So when I make it, I will get the phosphorus 4 atoms. Just heat it. When you heat it, what happens here? Remove the P4, that is 2 fours are 8 hydrogens are there and 7 oxygens are there. So I will get 4H2O, that is this one. Okay, 2 fours are 14 oxygens are there. There you will get 4 oxygens outside. So when 14 oxygen minus 4 oxygen if you remove, that time you get 10 oxygen remaining, and I left with the P4O10. If you not understand, you can see like this: H4P2O7, H4P2O7. In that I am removing minus water, that is 4 moles of water. 4 twos are 8 hydrogen, 4 oxygen. Here I will remove 4 oxygen directly here. It becomes O3. And here I will remove 8 hydrogens from this one and from this one. What I left with? P. 4 atoms are there, and here 3 plus 7 is equal to oxygen 10. Therefore, your correct answer is H4P2O7. Even though you can try here, sir, can I take 4S3PO4 and do like that? No. Hydrogens and oxygen ratio will be different. Here also it will be different, here also it will be different. Therefore, the option 4th one, that is called as peroxo diphosphoric acid, is the correct answer. Next question. Which of the following statements regarding ozone is not correct? This ozone compound comes in the 16th group chalcogen family. You should know the physical properties of ozone. In that he has given 4 statements. In that you have to identify the false one, that is which is not correct. Okay. So one by one we go on reading. You only understand which will be the wrong option. First I will draw the structure of ozone. Ozone will be having like this structure: O, thick bond, one dotted line, and this one. This is the ozone structure. The oxygen-oxygen bond length in ozone is identical with that of molecular oxygen. Molecular oxygen means O double bond O. Ozone means this one. He is telling that whatever the bond length is there, it is similar to this bond, whether it is correct or no. The ozone is a response hybrid of 2 structures. Response hybrid means mixing of two canonical structures will form the ozone or what? Yes. So dotted line is that later we can see. The ozone molecule is angular in shape. What is the geometry of the molecule is asking. Ozone is used as germicide and disinfectant in the purification of air. So first I made it clear. So already you know that ozone is used as germicide, disinfectant and purification of water. This is a true statement. Ozone molecule is angular in shape. This is called as V shape, bent shape or angular shape. This is also true statement. Ozone is response hybrid of two structures. Yes, it is also true statement. How means O, double bond O, single bond O. O, single bond O, double bond O. When you mix this, you will get the mixture of this one, which is called as a hybrid. This is also a true statement and this is a false statement. Why means here it is a double bond, covalent bond. Double bond length is different. Here it is one is coordinate bond, one is a covalent bond, and these are not actual double bonds, therefore the bond length will be different. So identical word is wrong, it is different. Therefore the false statement for this question is option A. Okay. Next question. Which of the following contains POP bond? This structure is related to oxo acid of phosphorus. If you know the central atom, if you know the valence electron, if you know the charge and to draw the structure, easily this type of questions can be answered. These are the low and middle level questions, not high level. We can go for this one. So which contains POP bond, and you should remember the names as well as formulas. If they give formulas, some students will write the answer easily. But if the names are given, you should know the formula. Hypophosphorus acid. The formula is S3PO2. Phosphorus acid. The formula is S3PO3. Pyrophosphoric acid. The formula is H4P2O7. And orthophosphoric acid formula is H3PO4. First you should write the formulas, then you should go for the structures. And when you draw the structure of this one, phosphorus in center, double bond O, single bond OH, single bond OH, and here H2 are there. Here I want S3PO2, so I will write H. So if you see, here only PH and POH bonds are there, no POP bond, this is not the answer. S3PO3, P double bond O, OH, OH, and here S3PO3, that is called as H. Again here also no oxygen, therefore this is the wrong statement. Okay, here also H, it is not O, this is the correct one, wrong. H4P2O7, PP, double bond O, double bond O, double bond O, double bond O. 4 oxygens are there, one here, and next one is OH, and here it is OH. So H4P2O7, right? So another one will be OH, and here also OH. It contains the POP bond. Therefore, the option 3 is correct. And last also structure here you can see just modification like that. So this is also wrong. So which contains the POP bond? But don't waste time by writing the formulas and this one. Easily you should understand where the oxygen atoms are more, it will contain the bridge bond. That will be the technique for this one. Next question. Among the following, which is the strongest oxidizing agent? So in P block or periodic table, you know that left side of the periodic table, that is a S block. Right side is P block. Left side are best reducing agent. Right side elements P block are best oxidizing agent. So we are learning P block element chapter. We know that they are the best oxidizing agent. So they have learned 4 halogens, and we know that down the group the oxidizing power goes on decreasing. F2 is the best oxidizing agent. Therefore the answer is a D. Because of small size, because of gaining 1 electron, that is -1. Hence, it is the best oxidizing agent. For this question, the answer is 4. Next one. The brown ring test for nitrates depend on. As you all of you know, in inorganic salt analysis, we will do the brown ring test whenever the nitrate salt is given. And in P-block element chapter, while you are learning the nitric acid by Ostwald process in chemical property, you learn about the brown ring test. So he is asking the brown ring test for nitrate depends on. So what is the answer for this one? Let's see. Reduction of ferrous sulfate to iron means FeSO4 will be converted to Fe or not. Oxidation of nitric oxide to nitrogen dioxide means NO will convert to NO2 or not. Next one is reduction of nitrate to nitric oxide means NO3 minus will convert into NO. This is the correct part. Oxidizing action of sulfuric acid means H2SO4 will get oxidized or not. These are the four options we have given. You know that the reaction, take a test tube, take a nitrate salt, to that add freshly prepared FeSO4, then you add this one that is called as a H2SO4. Slowly a brown ring test is formed and it forms the complex, that is FeH2O5CO, like that. Okay, so there you can see in the complex there will be an oxidation state of iron, but here it is 0, therefore this option is wrong. Okay. Oxidation of nitric oxide to nitrogen dioxide. First of all, NO will be not there in the nitrate salt, NO3 will be there, so there is no option to think about that. The reduction of nitrate to nitric oxide, yes, NO3 minus will be present in the salt solution, and after the complex the NO gas will be liberated, therefore the correct answer is this one. And last one, H2SO4 is the best oxidizing agent. It cannot oxidize itself. Therefore, the answer for this question is C. Reduction of nitrate to nitric oxide. 1 mole of magnesium nitride on reaction with excess of water gives. So, what he is asking, take magnesium nitride, react with water. But what you will get and how many moles you will get, he is asking. And the options are 1 mole of ammonia, 1 mole of nitric acid, 2 moles of ammonia, 2 moles of nitric acid. And whenever we know that nitrites, phosphates like that, when you react with the water, they will produce acids. But depending upon the metals. Okay, so nitric acid here it is not present due to the magnesium. First remove these two options about nitric acid. Then I left with 1 mole of ammonia, 2 moles of ammonia. Which one will be correct? Let's see. Magnesium nitrate formula is Mg3N2 plus H2O. When you react this with this one, you get MgOH twice plus you will get ammonia gas. This is the actual reaction. So for this reaction I can tell that only 1 mole of ammonia is formed, but everything is not balanced. Here 3 magnesium, here only 1 magnesium, therefore we should think of the balance in the equation. Here 2 nitrogen, here 1 nitrogen. When you do the equation balance, you will get the answer that is called as 2 moles of nitrogen, because here N2 is this one, okay? And here you should add 3 MgOH twice. How many hydrogens are there? 2 to the 6 hydrogens, 3 to the 6 hydrogens. Therefore, the 6 plus 6 is equal to 12. Make it as 6H2O. Then oxygen, how many are there? Twice. So we will get 3 to the 6 oxygen. Therefore, this will be the reaction. When you take 1 mole of magnesium nitrate, react with 6 moles of water, you get 2 moles of ammonia. Hence, the answer is C. Next one. Which is the strongest acid in the following? In our lab, we know that some acids are strong, some acids are weak according to Arrhenius theory also and everything. But here, these are the oxo acids of sulfur and chlorine. Both are different. Therefore, among this, which is a strong acid means, I will tell you one thing. Just to calculate the oxidation state, whose oxidation state will be higher, that will be the strongest acid. So let's calculate all the oxidation state. Here the oxidation state of chlorine is 1 plus x minus 6 is equal to 0. Therefore, the oxidation state becomes plus 7. Plus 5. And here, if you calculate 1 plus x minus 8 is equal to 0, it becomes plus 7. and here 2 plus x minus 6 is equal to 0, it becomes plus 4, and here 2 plus x minus 8 is equal to 0, it becomes plus 6. So if you see all the oxidation state, whose oxidation state is higher? Second option, that is HClO4, hypochlorous acid. Therefore, the answer is B. Whatever the acids they may ask, just this is the easy clue to find the oxidation state. Next question. Which of the following is an amphoteric oxide? So all of you know that there are different type of oxides: acidic oxide, basic oxide, neutral oxide, amphoteric oxide. Acidic oxide means mixture of non-metal and oxygen. Basic means metal and oxygen. Neutral means different oxidation state, and amphoteric means made up of either metalloid or stable element gas. Okay, when you see all these options, which will be amphoteric? Let's see. I will go from bottom. Boron oxide, trioxide. B is a non-metal, therefore it is a acidic oxide. And SO2, S is a non-metal, therefore it is also acidic oxide. Na is a metal, therefore it is basic oxide, like that. Like this also mechanically you can do. Zinc is a metal, but it is having a filled configuration 3d10 hence it acts as an amphoteric oxide. And what do you mean by amphoteric? Which act as a basic, which act as an acidic. So another one example you should remember, CDO. It is called as cadmium oxide, will also come for amphoteric in nature. The decreasing value of bond angle from NS3 106 to SBH3 101 down the group 15 of the periodic table is due to. So what is asking, when you go for the different hydrides of 15 group elements like NS3, PS3, SBS3, BIS3, etc., that time bond angle may increase or bond angle may decrease. So here he is telling NH3 is there. So if I write all the elements, you can understand: nitrogen, phosphorus, arsenic, antimony, bismuth. These are the 5 elements: NH3, BS3, ASS3, SBS3, BIS3. Down the group, what happens? Bond angle goes on decreasing. Why means N is having a lone pair, P is also having a lone pair, like that. But the size of the atom goes on increasing. These are all the reasons. So based on that, increasing BP repulsion, bond pair repulsion, increasing p orbital character in sp3. The s orbital p orbital character increase or decrease will not make the angle change. This option is already wrong. Decreasing LP repulsion, whether lone pair are decreasing electronegativity. So oxygen is nitrogen is more electronegative, Bi is less electronegative. Due to that, or what he is asking, electronegativity cannot decide the bond angle. Here only the option left is BP or LP repulsion. So you can see here, if I draw any one of the structure, we are having like this lone pair, H, and here H. So these are bond pairs, these are lone pairs. And there is only one lone pair, therefore there is no option of thinking BP repulsion. The answer is LP repulsion, that is lone pair and bond pair repulsion. So answer is C. Next question. P4O10 has dash bridging O atoms. So already in the first question we learnt about P4O10, that is phosphorus pentoxide. Now he is asking the structure. So from this, for this compound only, other type of questions also they asked in exam. P4O10 has how many sigma and pi bonds? All that questions I will tell you here only. 4 phosphorus are there. You should make 10 oxygen bonded. And how many electrons are there on phosphorus? Let's see here. 4p you should write in the tetrahedral manner. Each phosphorus is having 5 electrons. Using that, you have to make 10 oxygens. First, make double bond O for all the phosphorus. So now 4 phosphorus are used, 4 oxygens are used, 2 electrons are used. Now I left with 3 electrons of phosphorus. So I will make it as OP, OP, OP and OP here. Now again I used 4 oxygens and 4 electrons of phosphorus. Now I left with 2 oxygen and 1 electron. So what I will do is I will make the bond between this and this and the bond between this and this. So when I make this one, you can understand as dash dash bridging O atoms. Bridging means 1, 2, 3, 4, 5 and 6. The answer is 6 bridging. 6 POP bonds are present. I told you another question what they will ask. How many sigma, how many pi bonds are present? If there is a double bond, 1 pi bond will be there, and based on that here 1 pi, 2 pi, 3 pi, 4 pi. Remaining are sigma, 16 sigma and 4 pi bonds are present in this structure. Therefore, you should remember about this all. Any structure if you ask, you should make like that. The species that does not contain peroxide ions. So you know that oxide means oxygen oxidation state should be -2. Peroxide means it should be -1. Superoxide means it should be -1/2. So based on that, you should identify which is not containing the peroxide. And another one thing you should know that the oxidation state of the metal bonded with the oxygen. Then only easily you can identify which does not contain peroxide. Dash O dash O dash -1 -1. This is the peroxide linkage. So I will apply one method to understand this one. PbO2. If the oxygen charge is -2, then only you get Pb charge correctly. So what I will do is x minus 2 into 2 is equal to 0, it becomes +4. Lead charge is +4. Okay, here I will find 2x minus 4 is equal to 0, x is equal to +2. Here I will get like that. When I take -2 charge, SrO2, x minus 4 is equal to 0 +4. BaO2, x minus 4 is equal to 0, it becomes +4. So these are the charges when I take oxygen as a -2. But we should know the metal charges. Ba should show +2 and here it showed +4 due to the peroxide. Because I should not take a charge of oxygen 2, it should be 1, it becomes -2. So it contains a peroxide linkage, SrO2. So what happens here? SrO2 oxidation state should be +2 and here it is showing +4 because it is a second group element. Hence it also contains the peroxide linkage. And already you know about hydrogen peroxide, it contains the peroxide linkage. And here lead is the 14th group element. Its oxidation state should be 4. It is correct. Therefore, it is not having any peroxide linkage. Okay. So the next question will move. NO2 is the anhydride of. I told in first option question that is if they ask about the anhydride, what you have to do? Just remove the water from that compound which are given, or just add water to this one. What compound we will getting? That is will be the correct answer. Okay. Now NO2 plus H2O. If you add, you will get the compound H2NO2. This is not the correct compound. So I should add more amount of water. Okay. So like this, first I will go HNO3. If I heat, I will not get the water if I use a single mole. This option is wrong. HNO2 here also same. And this one they have given, none of this is there. When I combine this and this, I will get H2, N2O5. Just a mixture. Heat it. You should remove water. I will remove H2. I will remove one oxygen here, O, and I left with the compound that is called as N2O4. And this N2O4 will be dimer of NO2. Therefore, the answer is third one, HNO3 plus HNO2. Next question. Bleaching action of SO2 is due to its, when you go for the sulfur dioxide chemical property, you learn about many reactions and you should know that SO2 is a reducing agent also, it is a oxidizing agent also, act as a both. But it is having another one special property that is called as a bleaching. Bleaching means removing color or make it clean. So whenever you get a nascent oxygen, that indicates that it is a best bleaching agent. So acidic, SO2 is acidic, but due to this bleaching action is not there. Basic, no. Reducing, no. Oxidizing, reducing, yes. Oxidizing, no. Okay. By reducing power only we can identify the SO2. How means see, SO2 plus H2O, it gives nascent oxygen, okay, from this one. And when you take this nascent oxygen react with the colored matter, you will get a colorless matter, hence it shows that it is the best bleaching agent. So main is reducing property and nascent oxygen. Next question. White phosphorus reacts with calcium to form a certain compound. Again, on hydrolysis produces. Means two steps reaction. You have to go for this one. First, you go for white phosphorus formula. It is called as P4. React with the calcium metal. Metal is reacting with non-metal. Okay. And when you react this, make form a good compound. We know that calcium reacts with phosphorus to form calcium phosphide. But whether the formula is correct or no, no. Because Ca charge is 2 and phosphorus charge is 3. Therefore, the formula becomes Ca3P2. But here it is not a balancer. Okay. To balance it, what I should make it as 2Ca3P2. Okay. 2Ca3P2 means what happens here? Phosphorus becomes 4, but calcium becomes 6. Make it as 6Ca iron. And which on hydrolysis he is asking? If you take Ca3P2 and react with the water H2O, you get the CaOH twice. Plus another one product. What is that product he is asking? Let's see. TS3 phosphine or phosphine, S3PO4 phosphoric acid, P4O6 compound not exist, P4O10 phosphorus pentoxide. So first of all, think that the compound is not there, remove that option. We are adding water means the compound will contain hydrogen. Here there is no hydrogen, remove this option. Only I am left with the two compounds. Whenever you do this reaction, some gas is liberated, poisonous gas, which is called as a phosphine gas. Hence, the answer for this one is PH3. It is used in the preparation of the phosphine. Next question. Oxidation state of nitrogen in N2O, NO and NO2. In P block 15th group, we are having the subtopic called as oxides of nitrogen. So there are many nitrogen oxides are given. You should calculate the oxidation state. So first here redox reaction like that. So for you just I will solve. N2O dinitrogen oxide, NO nitrogen oxide, NO2 nitrogen dioxide. So he has given the three options in each one. So just that we can find out here. N2O 2x minus 2 is equal to 0 plus 1. Here x minus 2 is equal to 0, x is equal to plus 2. Here x minus 4 is equal to 0 is equal to plus 1. Where you see the option 1, 2, 4, that will be the correct option. That is the answer is A. 1, 2, 4. Next question. What is the oxidation state of phosphorus in H4P2O5, H4P2O6 and H4P2O7 respectively? Again the same question. Again I will solve, just you can understand here. H4P2O5, 2 plus 2x minus 10 is equal to 0. 2x minus 8 is equal to 0. 2x minus 8 is equal to 0. 4 plus 2x minus 10 is equal to 0. It becomes 2x minus 6 is equal to 0. Therefore, x is equal to plus 3. See the option here. All are 5. Here only one thing. Directly you can find the answer. But you should find out for all. 4 plus 2x minus 12 is equal to 0. 2x minus 8, x is equal to plus 4. Second option is plus 4. And third one, H4P2O7. 4 plus 2x minus 14 is equal to 0. 2x minus 10 is equal to 0. X is equal to plus 5. Therefore, the correct answer for this question is 3, 4, 5. Oxidation state of sulfur in Carrot's acid and Marshall's acid is. So he has given two questions. In that we are having the oxidation state. So what is that? We'll see first. First you should know what is the formula of Carrot's acid, and then you should know about the formula of Marshall's acid. Carrot's acid is H2SO5 and Marshall's acid is H2S2O8. If you know these formulas, find the oxidation state, you will get the answer for this one. So directly I will find 2 plus x minus 10 is equal to 0, x is equal to plus 5. So whether the plus 5 option is there? No, because it is a peroxomonosulfuric acid. This process is wrong. H2S2O7, 2 plus 2x minus 16 is equal to 0, 2x minus 14 is equal to 0, plus 7. So plus 7 option is also not there because it is a peroxodisulfuric acid. Whenever they contain the peroxide linkage, that time oxygen charge will be different. What is that? C. 2 plus x minus 4 into minus plus 4 into minus 2 plus 1 into minus 1 is equal to 0. Why I taken 1 into minus 1? Because it is a peroxide linkage. 2 plus x minus 8 minus 1 is equal to 0. X minus 9, x minus 7 is equal to 0. 2 plus x plus 1 second. S double bond O, OH, OH, OOH means how many? 1, 2, 3, 4, 5. Yeah, 3 into minus 2. 3 into minus 2, 1 into minus 1. Okay, then it becomes 6. And x minus 6, 7, minus 6, 7 minus 2 is equal to 5. Okay, this was the, I think the options given are wrong. Next question we will solve in the next session. So these were the few questions related to P block 14, 15, 16 and 17 group. Okay, thank you.